Hi, folks. We're going to take a look at number 6 from the Unit 1 Lesson 4 worksheet. So I'm going to focus in on A and B, but I might reference C and D. So notice they want us to draw a rough sketch and then check it using technology. So we're going to use our knowledge now of x-intercepts because this first one is given in factored form, which is nice because a lot of work's been done for me, but it also means I have to do a little bit of work because if I look at C and D, what I can get very easily from C and D are the degree and the sign of the leading coefficient, which are going to be important for drawing the sketch of this graph. So here I see degree is 3, leading coefficient is 1. I know the end behavior right off the bat. Here we're going to need to do a little bit of work. But remember, the only thing we're interested in is the leading term. So the highest power of x and its coefficient, in other words, the leading coefficient. So when I think of expanding this whole expression, I don't actually need to expand it. I just need to see what would happen, which would produce the highest power of x. So what I need to focus on is the highest power of x in each of the factors. So I look here, the highest power of x I'm going to get in x plus 3 is just an x. Whereas here, when I square x minus 2, the highest power of x I'm going to get here is an x squared. And here, when I cube 2x minus 1, the highest power of x I'm going to get is 3. So you realize that I could just add up the exponents for each of the factors. This is going to give me an x cubed, an x squared, so that's x to the 5th, plus another x to the 6th. So right away we can say that the degree is going to be 6. Okay, so an even degreed polynomial. Now remember, for the leading coefficient, I actually only need the sign. Here I've got a 1, okay? I mean the coefficient, and not the value of x, but the coefficient is 1. Here I have an x. When I square it, is going to give me x squared, so another coefficient of 1, so positive times positive. And then here, when I cube the highest power, I'm going to get at x cubed, I mean another positive number. So the highest terms are all going to have positive coefficients. So when I multiply them, still positive. So here that means A6 is going to be positive. I could actually determine the value, but the only thing I care about is the sign. Okay, so now we have the degree and we have the sign of the leading coefficient. So I know that the end behavior is that it's going to go to positive infinity on both sides of the graph. All right, now I'm going to focus in on the x-intercepts. So I have x-intercepts of -3, 2, and this will just be 1/2. Okay, so I'll just go up by ones here. I think that'll be enough. All right, so at -3, 1, 2, 3, there's an x-intercept. Okay, at 2, there's another x-intercept. And then here I have 1/2. But not only do I know that these three numbers are x-intercepts, I know how the function behaves near those x-intercepts. So here, it's going to just touch the x-axis because it's order 2. Here, it's going to go through the x-axis in a way similar to a cubic because the factor is cubed. Okay? So let's start. I know that, remember, degree 6, positive leading coefficient, positive infinity, and it's going to end at positive infinity. So I can start drawing this. And because -3 is an order 1, I know it's just going to go straight through. Okay? Now, I have a 0 at 1/2. So at some point, it's going to have to come back. And my 0 at 1/2 is going to be cubic. So notice here, I make a point of making it look cubic, okay? And then I know it's going to have to come back down for the 0 at 2. And because it's order 2, it's going to come back down and going to have to just bounce off. And so there we go. There's the shape of my graph, okay? So you see how this was going to have to come back up because I knew the end behavior was going to be positive infinity, but I also knew that it was just going to touch the graph because of the order 2, 0. Okay. Now at this point, you may be wondering why I seem to have made no effort to worry about either the y-intercept or where any of these maxima or minima occur, these local maxima and minima. Well, we're going to have a discussion about this later on. So for now, you're not going to worry so much about those values here. Okay. Once you get to C and D, I suppose you can use the y-intercept, but again, we're going to have to discuss how we're going to determine where those local extrema occur and what they are. All right, so let's move on to the next one here. So again, first thing I have to determine, move it over, is the degree of the polynomial. So again, here I've got x squared, and when I square that, I'm going to have an x to the fourth. Okay, and then when I multiply it by x plus 3, the highest power is going to be an x to the fifth. So here, my degree is 5. Okay, in terms of the leading coefficient here, I have x squared, so leading coefficient 1. When I square it, I'm still going to have 1 times x, so again, still positive, but then I'm going to be multiplying all the terms by -3. So in other words, my leading coefficient here, my a5, is going to be less than 0. So that means that as x goes to positive infinity, the y's are going to go to negative infinity, and as x goes to negative infinity, the y's are going to go to positive infinity. So that's going to help me draw my graph. Okay? But before I go on, I notice I don't have a linear factor here. Okay, but this is just a difference of squares. So this can be written as -3 x plus 3. And I know this is going to be x plus 1 times x minus 1, and all of that is going to be squared. So in other words, x plus 1 squared and x minus 1 squared. And so now I see that I have x-intercepts at 1, -1, -3. So again, we'll go 1. So 1, -1, and -3. Okay, but they're going to be zeros of order 2. All right, so remember what we said about our end behavior. It's going to go from positive infinity on the left and end up at negative infinity on the right. So I know that I'm coming down, and since it's a 0 of order 1, it's going to go straight through. Okay, then it's going to come back up and get to that 0 at -1, but it's going to be a 0 of order 2. And then I'm going to have to go down and come back up, and I'm going to have a 0 of order 2 again. So then it's going to bounce back down. Okay, notice here, I didn't assume that it would go as far down or further down. I don't know. So this is something that for now, we're going to leave for later on as to what's happening with these local maxes and mins. What I'm interested in is the general shape of the graph and how the function behaves near the x-intercepts. So an order 1 intercept and 2 order 2 intercepts. And so this is a decent graph for what I'm trying to draw. All right, so let's take a quick look here at Desmos and see what Desmos gives us. So if we look at this first one here, again, we notice that this goes way, way down. Look, past -2000 to the point where you can barely see the behavior here. But if we zoom in, we see that, yeah, it has the behavior that we expected. It acts like a cubic near 0.5, and then it just bounces off at 2. Okay, what we didn't have any information on was what the function would look like at the max and min, what those values would be. Okay. And let's take a look at the second one here. So again, let's zoom in a bit. Maybe even use there we go. We can use this view here. We see that it comes from positive infinity, goes through at -3, comes back up, and then bounces off the x-axis at -1 and 1, and then goes off to negative infinity. Okay, so again, if we compare, clearly we don't have the information as to where these local maxes and minimums are going to occur and how far down they go, but this is something to come later on. Okay, that's it for this one.